All right, hey, I've got chapter 5 practice test. I've got about 10 minutes before the bell's going to ring here, so I am going to get after it and just try and keep up. As always, if you don't understand something, please slow it down, make sure you're good with it, okay? Solve the equation, then graph the solution on the number line. I'm going to add 7 to both sides. I'm going to keep the inequality the exact same. Y is less than or equal to 12. I'm going to go ahead and put a solid line in right there, okay? And let's see here, if I were to put 7 right here, 7 minus 7 is 0. 0 is definitely less than or equal to 5. I'm good to go, okay? Right here, 8 plus k is greater than or equal to 13. I'm going to subtract 8 from both sides. That's going to give me 5. So if I put 5 here, let's say I put 6 here and 4 here, I'm going to put a closed circle. And I'm going to the right, okay? If I multiply both sides of my inequality by 3, okay? So now I'm going to put 27 here, 28, 26, okay? Open circle, going to the left, okay? What I'm going to do on this one is I'm actually going to multiply both sides by 5. Okay, now what that's going to give me is a negative. I didn't multiply by -5, so I'm not going to flip the inequality. I'm going to keep the inequality the same. You end up having 10 over 3, so 3 1/3. Okay, 3 1/3, 10, yep, 3 1/3. So z, I'm going to write this on the other side. Remember, we like to write it on the left-hand side. Z is smaller than 3 1/3. So if I were to go ahead and put 3 1/3 right here, 4 1/3 right here, and 1 1/3 right here, okay? What we're going to know is that this is going to be open circle going to the left, okay? If I divide everything by 2.8, we have 9.8 divided by 2.8. Got 3.5. Now again, it might be beneficial to write it on the other side. Okay. So if this is 3.5, let's put 4.5 there. So I went over 1, 2, 3. So I'll go over 1, 2, 3. This is 4.5 here. Okay. Less than or equal to 3.5. Put that there. There you go. Okay. All right. Now the next one, I'm going to divide by -3. So m, flip the inequality because I'm divided by a negative, is equal to or is greater than 6. Okay. So if this is 6, 7, 5, okay, greater than 6. Boom. Okay. Number 7, if I subtract 8 from both sides, and subtract 3t, we then have 2t. Ooh, I want to divide by 2, don't I? Getting a case of yawns right now. Whew. Okay, so I'm going to go with t is going to be less than or equal to -5.5. Even though I divided by 2, well, because I divided by 2, I kept my inequality the same. Okay, I didn't change my inequality. So if I was to make this 5.5, 6.5, 4.5. We're going to go less than. All right. So, yeah, you have those there. You can check them if you want to. Okay. Solve each compound inequality, then graph the solution set. So, if I divide by 7, W is going to be greater than 2, and W is going to be less than 3. Erase that. So if I'm going to do this, greater than 2, less than 3. Okay. So if I put in like a 2.5, 7 times 2.5, 17.5, excuse me, 17.5. And 2.5 is less than 3. So yeah, 17.5 is greater than 14, and 2.5 is less than 3. Okay. Down here, I'm going to multiply both sides by 3 since we're dividing by 3. Over here, I'm going to actually subtract 5. Over here, W is going to be rounded for 2. Okay, greater than 2. So here we have W is less than 3 and greater than 2. Connect that there. Okay. So if I go ahead and put in like 2.5, 2.5 divided by 3 is less than 1. That is correct. Okay, 2.5 divided by 3. 2.5 times 3 is 7.5 plus 5 is 12.5. Oh boy, I just realized something. This is an or statement. Okay, so if W is headed this direction forever and W is headed this direction forever, guess what? This entire thing, all real numbers is possible. Okay? And I'll choose a number that would have been outside of that. Let's say I choose 0. 0 divided by 3 is 0, so it's less than 1. Got it. If I was to plug in -3, -3 divided by 3 is -1, -1 is less than 1. Got it. Okay? If I chose something like 4, 3 times 4 is 12, plus 5 is 17. Is 17 greater than 11? It is. Okay? So we only need it to be true in one of those two. Next one. If I subtract 2, okay, so if I go ahead and grab 3, I end up with a 2. Okay, so x is greater than 2. Not -2, sorry, 2. Okay, the next one I subtract 4 from. I'm going to divide through by -7. X is going to be greater than or equal to 3. Okay. So if this is an or statement, and I want to put this one down here, I'm going to go ahead and fill this in and head it this way. But here's the deal. This one right here swallowed that one up. Okay, because it's an or, it's either or. So if I go ahead and take 2.5, 2.5 times 3 is 7.5, plus 2 would be 9.5. So that one works right there. Okay. If I was to put 7.5 over here, or 2, what did I say? 2.5, -7 times 2.5 plus 4. Okay, and that is less than -17. Oh, hold on. Oh, it's an or. Didn't have to have that. But if I get over here about 4, -28 plus 4 is -24. And then from there, -24 is smaller than -17. Okay. Absolute value equations. Here we go. So we have z plus 4 is greater than or equal to 7. And the other one, z plus 4 is less than or equal to -7. If I subtract 4, if I subtract 4. And so from here, greater than symbol means it's an or. So if I'm at greater than 3, got it, less than negative 11. All right, so realized as I was taping there that I wasn't down on my problem here. So hopefully my work makes sense. You can go back and listen to it if you want to. But yeah, that's how we're going to go ahead and solve for z less than or equal to negative 11. And it doesn't look like I put it right on it. I probably should move that over a bit. Negative 11, I think, is right there. There we go. And then greater than 3. Okay. So for number 14, again, I'm going to separate this into two different equations. Now again, I'm going to flip that inequality and make it the complete opposite there. Okay. So if I add 1 to both sides, I have less than or equal to 5. Adding 1 to both sides here, I have negative 3. Okay. So if we go ahead and do this, let's see here. This is an and statement. This one was an or, remember. This is an and. So I'm going to go ahead and do from negative 3 to positive 5. Right there. Okay. Number 15. Again, I'm going to set up two different inequalities. 2x minus 5 is less than 3. And then 2x minus 5 is greater than negative 3. Okay, now again, this is an and statement right here, an and problem. So I'm going to subtract 5 from both sides. Oh, subtract, what am I doing? I want to add 5 to both sides. Sorry about that. Let's go 8. Adding 5 to that side, I get 2. And I'm going to divide both sides by 2. So x is going to be less than 4, and x is going to be greater than 1. Okay. So as I look at this, and statement greater than 1, less than 4. Okay. And so we end up having that right there as our range of possibilities for x. Okay. Okay. So again, don't forget to separate those and then flip the inequality along with the opposite value when you do the second equation. Taking a look at the backside. Don't go too far down. There we go. Okay. We have y is less than or equal to 3x. Now again, you can plug this into Desmos if you want to make sure you've got this down. I'm not needing Desmos, so I'll go ahead and graph the slope of 3 over 1. And the y-intercept is not present, it is a 0. So the y-intercept is 0. So I'm going to go 0, and I'm going to go slope of 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay? Now from there, I want to go ahead and determine it's less than or equal to. So I know it's going to be a solid line, and I should probably maybe do it like this. Solid line. Okay, I'm off just a bit there. Okay, solid line. And I'm going to go ahead and shade below it's less than. Okay, so any solution is in this shaded area or actually on the line itself. Okay, shaded below. Now the next one, I have to get y by itself. So if I have this as my equation, I'm going to go ahead and add 4x to both sides. Okay, I'm then going to divide everything by 2. So y is going to be less than 2x plus 4. Okay, so as I graph this out, up 4, 1, 2, 3, 4, got my point right there, and a slope of 2. Now, if I go up 2 over 1, you can kind of guesstimate where that's going to be. I'm going to go down to left 1, down to left 1, down to left 1. Okay. Now, this time the line is going to be dotted. It's not or equal to. So as I go ahead and graph this out, dotted line here.
okay? And we're going to, again, we are less than, and so I'm going to shade below for a second time, okay? All that shading below. Now, what inequality has a solution set shown in the graph, okay? Well, the first thing I'm going to do is I'm going to determine the shading. That's the easiest. It's above. So I'm looking at greater than. It is solid, so I'm going to say or equal to, okay? The y-intercept is going to be at -1, so I'll do this. B is at -1, and the slope, 1, 2 over 1, 1, 2 over 1, looks like it's a +2 slope, or 2 over 1, however you want to go ahead and put that down. So if I do this, y equals mx plus b. And that would be your equation right there. Again, Desmos would be a great way to double check your answer. All right, now the next one. Matthew is shopping for shoes and socks. He has $75 to spend. The shoes he likes cost $28. And the socks cost $4. Write an inequality for this situation. Can Matthew buy 2 pairs of shoes and 5 pairs of socks? Okay. So here's what we're going to do. I'm going to say x, hold on, x equals the number of shoes, and y equals the number of socks. Okay? So from there, if I know if it's $28 per pair of shoes, 28x. If it's $4 per pair of socks, 4y, okay? And then we has $75 to spend. And inequality to say, hey, that's the maximum dollar amount you can spend. I'm going to say you're going to be less than or equal to $75. Okay? Now, let's see here. Write an inequality and then determine if this is possible. So 2 pairs of shoes would be this. And 4 pairs of socks, 5 pairs of socks, would be that. So the question is this less than or equal to this? So this is 56 plus 20, 4 times 5. Well, that ends up being 76. I'm sorry, Matthew, you cannot buy 2 pairs of shoes and 5 pairs of socks. Okay? Not possible. The last one, write and graph an inequality that would include the coordinates. Okay? So the first thing I'm going to do, 2, 0, there's 1 point. 3, -5, 1, 2, 3, -5, 1, 2, 3, 4, 5. And then -2, 6, 1, 2, 1, 2, 3, 4, 5, 6. Okay? Now here's what I'll say. You can have lots of different possible answers here, okay? So you can have something completely different in mind as long as it fits with that. Desmos would actually be a great way to, if you plug in those values and then plug it in an inequality, as long as it shades over the top of those values, I'm fine, okay? So I think what I'm going to do is I'm going to make, let's see, my y-intercept, I'm going to make it -1, 2, 3, 4. So my y-intercept is -4. And I'm going to make my slope, let's say -2 over 1. Let's say a -2 slope. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. Yeah, that works. I have a -2 slope. Okay? So my inequality, if I was to do this, okay, you can go ahead and put a dotted line across those there. Okay, and if it's got to include these, I'm going to say it's got to be greater than. You can also say greater than or equal to, but I'm going to say it's going to be greater than the slope y equals mx plus b. And I'm going to say that will be my inequality that swallows up those other 4 points or the other 3 points. Okay, so that took a long time. I hope that made sense to you, what I was doing there, okay? If it didn't, let's talk before the test. I don't want you to come to the test unprepared, okay?
do your best. I think you guys can do really well in this. I've been very impressed with what you've been doing in class. So, best of luck, and I will see you later.